In this question, you've been asked to determine which of the following differential equations can be solved through separation of variables, which really just means solving it algebraically. So let's look at a couple examples here. If we had dy dx equals y times x, we could separate by multiplying the left side by dx and dividing everything by y. So we'd have dy over y equals dx times x. Now we could integrate both sides because the x and y are separate. Now let's look at the next one. Dy dx equals y plus xy. Well, if we were to factor out a y, we would have 1 plus x equals dy dx. Now I could divide by y and multiply by dx and have dy over y equals the quantity 1 plus x dx. Well, what was the same with both of these? This first one was written as a product, y times x. The next one after factoring was written as a product, a term of y and a term of x. So it appears as though anytime we can get something in the form of dy dx equals some function of x times some function of y, then we'll be able to multiply by dx and divide by that function of y, and we'll be left with dy over a function of y equals a function of x dx. Let's look at this equation. F prime of x equals x plus y. Well, it can be confusing to see it in a different form, but this is really just dy dx equals x plus y. So it seems logical. We can just subtract y. So now we'll have dy over dx minus y equals x. And now we could multiply everything by dx. This would cancel, but to do this right, I'm really going to have dy minus. Everything needs to get multiplied by dx, so I'd have minus y times dx equals x dx. And as you can see, we're still not separated, and there's going to be no way to separate. And the reason why is because we started with a sum of x and y, not a product of x and y. So this one cannot be separated. This is a no-go. Let's look at this example. Dy dx equals e to the x minus y. Well, it looks like it's going to be really hard to separate these until we remember our log rules, which tell us that this is really the same as e to the x over e to the y. Since it's the same base, x squared times x cubed would be x to the fifth, but would also be x to the 2 plus 3. Similarly, x to the 2 minus 3 could be written as x squared over x cubed, just like we've written this here. Now we can separate these. I'll multiply everything by e to the y and dx. And on the left side, we will get e to the y dy equals e to the x dx, and it would be simple to separate those. They've already separated. It'd be simple to integrate and solve. Let's look at this last one. We could multiply everything by dx, and we'd have dy equals e to the x over y dx. But I haven't separated the x and y yet in the exponent. So I could think of this as an exponential equation where we have dy equals e to the x to the power of 1 over y dx. And so I can't undo this in any other way than I could take the y root, sorry, excuse me. I have the 1 over y, x to the 1 over y, because that's the same as x times 1 over y. But I would have to take the entire right side and raise it to the y. Same thing on the entire left side, but I still have not separated properly. The reason I'm not separated properly is this y would undo that 1 over y, but I'd still have e to the x dy to the y power equals dy to the y power. And so there's no way to undo this. And the reason is that this original problem could not have been written as the product of two functions, one with x and one with y. If it can be written like this, it would work, but that would be e to the x minus y. So now, with that lead-in, let's try these three problems here. The first one is written here. I'm trying to separate and I'm trying to write as a product of x and y. Well, I can see that there's x terms in both, so I could factor a 2x out, and I would be left with y minus 3 equals dy dx. Now you can see this is a product. My next step, of course, would be to divide here and multiply by dx. But we're not even going to do that because as soon as we can get it to the product step, we know we're good. So one works. The second one is written as f prime, but that won't confuse us. We'll rewrite this as dy dx equals 2e to the 2xy. Well, we can rewrite this using our power rules as dy dx equals 2 times e to the 2x times, wait a minute, we can't rewrite this. This can't be written. The next one could be, because here we have exponents that are added, but this would have to be written as 2e to the 2x all to the power of y, and we're not going to be able to separate these just like we couldn't separate them on the other side. So this is non-separable. Here we have a no. Now we'll look at the last one. Using our power rules, but the same base with added exponents will equal 2 times e to the 2x times e to the y equals dy dx. Now we can see our product. We could lump these together and say this is the product of a function of x, and here is the product of a function of y. What would it look like? dy over e to the y equals 2e to the 2x dx. So 1 and 3 were separable, but the middle one could not be separated.